Okay, we've talked about multiplying monomials and polynomials. We're going to talk about dividing now. And so, uh, as we've talked about the order of operations, you have your parentheses and exponents up at the top level, then multiplication and division, and last, addition and subtraction. So, anytime that I was multiplying two monomials together, so x squared times x to the third, if that's multiplication going on, when I zoom in just to the exponents, I'm adding those exponents together, so it drops down a level from multiplication to addition as I zoom into those exponents. So those exponents added together. Similar thing's going to happen here. If I'm doing an exponent, a variable with an exponent divided by another one with an exponent, then as I zoom into just those exponents, I'm going to subtract. And so the way that works is, here for instance, on number 1, I have x to the 5th, which means I've got x times x times x times x 5 times up on the top, and on the bottom I have x to the 3rd. And so if we know anything about our fractions, anything that I have in common on top and bottom will cancel out. So what I end up doing is say, well, those cancel, and those cancel, and it just leaves me with 2 on the top. And so that would end up as x squared on the top and just a 1 on the bottom, because that's x to the 0 power. But I can just write that as a regular x squared. If you notice, really what's happening here is I'm just doing 5 minus 3. Okay? And so basically my monomials, my quotient rule would be if I have x to the a over x to the b, it equals x to a minus b. And so you could really think of it as, I'll take the larger one. So for instance, on number 2, k to the 12th is larger than k to the 2nd. So if I do 12 minus 2, it's 10, but it doesn't hop up to the top. All that it means is that I get k to the 0 power, which would just be 1 on top. And on the bottom, I'd still have k to the power of 10 left. So you could think of it as that way, just since we haven't talked about doing the negative rule. Basically, the negative flips it over on the fraction. But for today, as we're talking about it, think of it as canceling it out and leaving whatever's left over. So now look what happens on number 3. If I have m to the 3rd on both the numerator and denominator, these cancel out all the way across. And so just like on the bottom here, I said that was equal to 1, and on the top here, when that was equal to 1, when everything cancels out here, it's not a 0, it would just be a 1, because I get m to the 0 power on both of them, and so my answer would just be 1. So that's another rule that we haven't really named specifically, is if I have x to the 0 power, or anything to the 0 power, that's going to just be equal to 1. So that makes some of these abundantly easy for you, especially if they're like number 3, where they cancel out pretty quickly and easily. So now I can go through as I work through these. And if you need to, it's perfectly fine on a piece of scratch paper or the side of your paper. Say a to the fifth, that's 1, 2, 3, 4, 5. B to the fourth, 2, 3, 4, over a to the second power, b to the third. And then you can just go say, well, those cancel out. And those right there cancel out. Say, well, there's 3 A's left on the top and 1 B left on the top. So that means everything on the bottom turns to 1. So I'd get A to the third, B, or just B to the first. Okay, you can also say, well, 5 minus 2 is 3, 4 minus 3 is 1, and look at it that way. Okay. Thing is, when you get to number 5 and number 6, you get some with a lot larger powers. So writing out 12 Q's and 16 Q's on the bottom gets to be a little bit of a pain. So if we just think of this as the bigger numbers on the bottom, so I do 7 minus 4 gives me 3. So since I'm getting something on the bottom, I had 3 P's left over, so P to the third power. Then Q, the larger numbers on the bottom again, so 16 minus 12 would be 4, so Q to the fourth. And then that means there was nothing left on top, so I just put a 1. So as I go through and do that, you can also, as you look at it, say, well, 20 minus 5 would give me 15. So cross that out and put a 15 there. 9 and 9, so both of those cancel out and they turn to 1. And 1 times anything else is itself. And then z to the first minus z squared takes away that. And that just goes to the first. So for this one, I end up with x to the 15th on top and just a single z on the bottom. And then you'll have some that have numbers as well. So when you're looking at those, just like we multiplied coefficients before, you're going to divide coefficients. So I would do 6 divided by 2 to start out with, which would give me 3. And again, we could say, well, 6 divided by 2 is 3. The larger one's on top. So as I'm doing this, that would be a 3 on top. And I say 4 minus 3 just gives me 1x. And so there's nothing on the bottom. I could put a 1 down there, or I just leave it like it is. Either way. This one also works if I 4x is on top, 3x is on bottom, 3 of them cancel out, and there's 1 left. Number 8 kind of works out the opposite way. Since 14 is the bigger number, if I do 14 divided by 7, that'd be 2. And so the larger number was on bottom. So really you're just simplifying it. It's saying both of those divide by 7. 7 divided by 7 is 1. 14 divided by 7 is 2. That's how we get our 1 over 2. Then I have 2 r's on the bottom, 1 r on top. So those cancel out and leave me 1 r there. Same with the s's, 1 on top, 2 on bottom. And so I end up with 1 over 2rs. Okay, the negative sign, if we have ones with negatives, would stay with the number. Unless number 10, where I have negative 15 divided by negative 3, that would give me a positive 5 because a negative divided by a negative. So we'll do one or two more here. Negative 36 divided by 4 would give me a negative 9. That's on the top. And then c squared and c squared, those cancel each other out, become a 1. And then d to the third, d to the fifth. Looks like if I do 5 minus 3, I'd have d squared left on the bottom. So negative 9 over d squared. So you'll notice sometimes I end up with a longer line than I need to, but I do that just because as I'm subtracting, I can take and move it down here. If you're canceling out like this and being able to write it around it, might rewrite the problem like that. But then if you're one that likes it a little bit neater, you can have it shortened to where it needs to be. Okay, same things taking place there. Then when we're looking at the mixed practice down here, simplifying each expression, one of the things we haven't talked about, or we may have talked about, it just depends on what order we do this in, is doing 3x to the fifth squared. Basically, this squared up here distributes to both of them. And so if I do negative 3 squared, that'd be negative 3 times negative 3 is 9. And 5 x to the fifth squared would be x to the 10th. Then I can go through and say 27 x to the third, and I can divide that like normal. So as you work through these, get some good practice on that, and hopefully this helps you work through dividing polynomials